topic is all about combined gas law, formulated by the physicist Benoit Paul, Emile Clapeyron, performance task #1. In 1834, French physicist Benoit Paul Emile Clapeyron combined the old gas law into one single law, which was called combined gas law. The combined gas law combines the three gas laws, Boyle's law, Charles' law, and Gay-Lussac's law.
What is combined gas law importance? The combined gas law allows you to derive any of the relationship needed by combining all of the changeable pieces in the ideal gas law, namely pressure, temperature, and volume. It states that the ratio of the product of pressure and volume and the absolute temperature of a gas is equal to a constant. The combined gas law states that the pressure of a gas is inversely related to the volume and directly related to the temperature.
Temperature is held constant. The equation is reduced to Boyle's law. Gay-Lussac's law states that at constant volume, the pressure and temperature of a gas are directly proportional. One example of the combined gas law applies to scuba diving. In scuba divers, human lungs are the container that hold the gas. The pressure in water is greater than pressure in air, and water pressure increases with depth. With each additional foot that divers descend, water pressure rises.
A 25.0 ml bubble is released from a diver's air tank at a temperature of 2.90 atm and a temperature of 25 degrees Celsius. What is the volume of a bubble when it reaches the ocean surface, where the pressure is 2.05 atm and the temperature is 30 degrees Celsius? So here is the formula. Initial pressure times the initial volume over the initial temperature is equals to final pressure times the final volume over the final temperature. So V2 is equals to P1 times V1 times P2 over P2 times T1. So let's substitute. 3.90 atm times the 25.0 ml times the 303 Kelvin over the 2.05 atm times the 299 Kelvin. So equals to 29,542.5 over the 610.9. So our final volume is equals to 48.3 ml. A gas in a container has an initial volume of 7 liters and an unknown temperature. The final temperature is found to be 250 Kelvin with a final volume of 12 liters. What is the initial temperature? So the formula is initial volume over initial temperature is equals to final volume over final temperature. So we have here T1 is equals to 250 Kelvin times 7 liters is equals to 12 liters times T1. T1 is equals to 1750 over 12 is equals to 12 liters times T1 over 12. So we will get a initial temperature is equals to 145 Kelvin.
The flame meets the air inside the glass and the air expands. When the flames goes out, the cooled air contracts, the vacuum sucks the water into the glass because it goes from an area of low pressure to an area of high pressure.
So hi guys, a heuristic morning to all of you. My name is Tumaque, and now we're going to make a combined gas law experiment. So now, what is combined gas law? We know that the combined gas law consists of 3 laws. The first one is the Boyle's law, second one is the Charles law, third one is the Gay-Lussac law, wherein the pressure is directly proportional to the temperature and inversely proportional to the volume. So now we need these things to make the experiment. So the first one, we need the bottle. Second one, matches. Then hard-boiled egg. And the fourth one is a piece of paper. So the air molecules in the bottle were heated to the point where the burning paper was dropped. The air molecules sought to spread, but they became stuck where the egg was. Because of the shortage of room, air molecules began to press against the wall, increasing the pressure.